Dear students, we'll proceed to solve some more problems in Pyramid 2. Problem number 1 goes like this. A hexagonal pyramid 25 mm side of base and 50 mm axis length rests on HP on one of its corners of the base, such that the two base edges contain the corner on which it rests makes equal inclinations with HP. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and to VP at 30 degrees. I had made a discussion clearly that we have to take the beta angle for VP. I had drawn the initial figure of hexagon right hand side taking a corner, top view, front to the hexagon pyramid is drawn. That's the initial figure. Then I'll make it inclined to HP at 40 degrees. The axis will be inclined to HP at 40 degrees. The base will become 50 degrees. Then I'll find the beta angle and shift. So initial figure, first step, second step I am going to show slowly. Please observe. The base is inclined at an angle of 40 degrees to HP. So measure this base here, reproduce here at 40 degrees. Measure the base and reproduce at an angle of 40 degrees to HP. Draw here at an angle of 40 degrees. Draw here at an angle of 40 degrees. Measure the length of the base here. Mark the length of the base here. That's at an angle of 40 degrees. Locate all the inset points thoroughly. Locate all the inset points thoroughly as per the dimension. Draw here perpendicular, that is axis. Axis is given as 50 mm. Measure this 50 mm axis length. Mark here 50 mm axis length and complete the figure. Complete the front view. Complete the front view. Complete the front view in this manner. Complete the front view in this manner. We have here O dash. This axis angle is at an angle of 40 degrees. The base is already drawn at an angle of 50 degrees. 50 degrees. Name them thoroughly. We have here A, B, C, D, E, and then F. So project and get the top view. Project and get the top view. When you project, you find the apex is nearer to the look arrow, base is away, base only outer boundary seen, not fully seen. Draw the projectors from all the base points. Draw the projectors from all the base points in this manner into HP. Draw the projectors into HP from the front view. Draw here in this manner projectors. Draw the locus lines from the previous top view. Regular procedure. Draw the previous top view. Locate the points here. You have the points here. That is A. This is B. We have a C, D, E, F, and that is O. When you look in the top view, I told you already, you have a visual number of infinite number of visual rays towards XY. You get the top view. When you keep moving with the visual rays, first you come across OF, second one OA, OE, third one OB, OD, the last one is OC. Let me indicate here all the details here. OF is the first one. O dash, F dash, OA, OE. We have here O dash, A dash, and then O dash, E dash, then OB, OD, O dash, OB, and then OD, then OC. That is OC dash. In this order, you please draw the top view here. OF is the first visible slant edge. OF is the first visible slant edge. Next is OA, OE. OA visible, then OE visible slant edges with the outer boundary line. Draw here the outer boundary line. With the outer boundary line, you get two triangles visible. Join the outer boundary line. Two triangles visible. Next we have OB and OD. They happen to be outside the previous triangle. Please join them. In this manner. Visible. Then again outer boundary visible. Like this you have the triangle seen. Whereas OC automatically becomes a dotted line. So in the process you have BC is a dotted line. CD is a dotted line. From here you can project the bottom point here. This is O1 dash. Project and get the point here. That is O1. That is O1. No need to draw now O1 to O. The apparent axis no need to draw because already full line there. OF is visible, already full line is there. When axis must be drawn when the path is clear. When the path is not clear, when you overlap with the full line or dot line, no need to draw the axis, please. Just indicate the center, that is enough. Now, as per the problem, I cannot shift this directly here. I have to find the beta angle. I have to find the beta angle here. It says incline to VP at 30 degrees. So I'll just find the beta angle, shift the entire figure to beta degree, then project and get the final figure. 30 degrees is given the problem. Draw here a 30 degree line. You draw here a 30 degree line. That is the 30 degree line. Draw here a 30 degree line. That is a 30 degree line. Measure the true length, that is 50 mm. True length on axis to measure 50 mm. Draw here true length. Measure 50 mm, mark here 50 mm. That is the true length. Just because it is true length top view, let me give an indication as O2 and draw here a locus line. Draw here a locus line parallel to XY. I repeat, 50 mm true length is measured on 30 degree line. True length measured on 30 degree line. This is the point O. Measure O1 apparent length. Measure O over apparent length. We O as center, you cut off here, you get here O1. You get here O1, that is an axis. This is an axis. This is an axis. You will agree with me now, this angle, with this angle is beta angle, which is greater than the 30 degree angle. Now, how to reproduce this figure here? Very simple. You extend the beta angle. You extend the beta angle. Then from the beta angle, you create the entire box here. You create the entire box here. So we have the O1 here, we have O1 here. Measure from here, left vertical line, right vertical line, both are same measurements. From here, measure left vertical line and right vertical line. Draw here perpendicular to beta line. Perpendicular to beta line. From here again, measure leftmost vertical line, rightmost vertical line, F and C. Again from here, you measure and then mark here. Again draw here perpendicular to the beta line. That's what the measurement from here taken. Again from O, top horizontal line and the bottom horizontal line, both are same. Measure here, draw here, from here. That's the perpendicular line for the beta line. So draw here top horizontal line and the bottom horizontal line. Your box is ready. Locate all the points in order. So we have here A, that is B. Then we have here C, there's a point C, that is D, E, and then F, Join them in order as we have here. So AB, then AF is also visible, that is visible, then FE, then ED, then we have this point O, but CD, you can make out very clearly, I am just reporting the same thing. CD is a dotted line, then CB is a dotted line, You measure the point O. So measure the point O, you get the point O already located here. Join them. You can join them in order. All this you can join them in order. That is the reproduction of this figure is reproduced here at an angle of beta, not at 30 degrees. Now project and draw the front view, please. Project and draw the front view. In the front view, because the base is nearer to you, the base is fully seen here. The base is nearer to you, the base is fully seen here. So draw the projectors. I just wanted to see you complete this figure by yourself. Draw the projectors. This is point O. This is the point O. Draw here the locus lines. That is F. All the locus lines are joined. So project now. This point you get here actually O dash. Then we have this is F. You can locate here F. This is F. So locate the point F. Locate the point here. That is F dash. A and E. A. Locate the point here. This we have here A dash. Then E. we have a point here E, locate the point here E dash, B and D, B. You get the point here, from here, locate the point here B dash, then D, locate the point here, that is D dash, then C, you get the point here C, locate the point here C dash, C dash. So you join the front view, base is fully seen, then draw the complete figure. I just wanted to leave at this stage so that you can work them, the lines that is visible or not visible, which I am going to give a hint for you. First visible is OB, I'll write there very clearly, OB. Second visible is OA, that is OA, I am telling you towards XY line. Next is OC, OF, OC and then OF. Next is OE, OE and then OD. In this order, you start joining the lines. First make the base fully visible, then join the length. You get the triangle, triangle, triangle. Any line goes inside, make a dotted line, otherwise you have to make a full line. That will be the completion of the problem. I am just leaving it to you to make a small work. Because having done so many problems, you can complete this front view of the hexagonal figure. Finally, let me make a small conclusion. Hexagon pyramid, 25 mm side, 50 mm height, resting on the corner, base inclined at 40 degrees. We have just made an inclination, got the top view. Then this top view is inclined at an angle of beta angle, projected and got the final front view, which I want you to do it by self. Students will do the final answer by self. I think a little bit and get the things. I have given a hint how to proceed. You please complete. You feel happy, when you can complete by yourself the final figure. That is the answer for the problem number 1.